Okay, so I want to make a game. I haven't played with Python in quite a while, so I'll just do a Python game, right? Let's do a new repository. Let's call it falling. One of my favorite, I guess you guys can guess from what show this is. I'll make it public. I don't want to read me what license. General public, right? So anyone can just use it for whatever. Create the repository. Okay, now I want to clone this. So let me get PowerShell open. You guys can see the screen. DC workspace. That's my other machine. What is in here? CD stuff. What is in there? Okay, so I've got a bunch of projects in here, DL sites, things, blah blah blah. I'd like to then do git clone that, right? And it should clone into a directory called falling. It should clone an empty repository. So now if I do cd falling, there we go. Great. So I should have Python installed, right? Huh, that's odd. I don't care what Windows is telling me. Python 3. Nope, don't have Python installed. It's so odd that I don't have Python installed. But okay, cool. Let's get it through the Windows Store. This is obviously a Windows machine, as you can see all over the desktop. Hopefully that all works. I'll come back when the download has succeeded. Okay, great. So Python was installed and I just tested it. As you can see, it has Python, so we'll just call it Python. We are in this falling repository. I want to start off with just a plain boring PyGame. So what I need is to install it. I had this open. Yeah, pip install PyGame. So let's see what that does. Well, that's quick. That's nice. Give it a second to install and then we'll get back when it installed. Great. So what's in here? Oh, that's it. Okay, cool. So what do we do now? I'd like to create a file called falling the pie. Oh, touch doesn't exist on this machine. Oh yeah, I've been on Linux for a while. Did I install Nano? Nope. Okay, cool. Then I'll just do VS Code for this. So in VS Code, I would like to just open that folder, right? Open folder. Stuff. Falling. Select folder. Don't save. We looked at that in the previous video. It should be fine. So new file. Let's just do control this and name it falling.py. Right. So we've got falling.py. All we need to do is just grab the example file. Let's see, what do we have? We've got screen full purple and it's not the quit event. I'm guessing it's the little X that you showed there. Here's a little bit of a fleshed out example that moves something around on the screen. I guess that's fine. Let's see what this does. So I wouldn't recommend at any time just copying and pasting code onto your machine like this, but live and learn, right? What we should have done was run this in an isolated environment like a container, but because it's GUI based, Docker doesn't work that well. I could have spun up a VM to do this. As you can see, this is my machine with all my bits and pieces installed. So maybe not, but let's see what it does later. Install the update later. So what this does is imports PyGame, init, gets a screen with 1280 by 720. I actually want 800 by 600. This is a laptop screen, so just bear with me. We get the clock, we set running to true, and delta time equals 0. So we set up a player position, which is a vector 2 for screen get width over 2, screen get height over 2, which means it's sitting smack dab in the middle of the screen. While this flag is set to true, it will loop through, and then what do? Grab the events. Let's go read about the event. Doesn't matter. Grab the events, screen.fill with purple. I don't like the fact that you have to specify the color with a string, which means this thing does a lookup. Could be hash table, which is just O of 1 lookup, but I still don't like it. Anyways, PyGame draw circle screen red again. I don't like specifying colors with text. That doesn't make sense for me. I like the numerical values, the RGB. Now they say PyGame keys equals get the pressed keys, and if keys PyGame KW equals true. I'm guessing this gives you an array of all keys. We can print this out actually. I'd love to see what's inside of this thing. So before we set it to running, then I just wanted to print keys, save, and then you can get a terminal open here, and we can see if we can do Python. How do you run this? Do we just do Python and then the script name? Let's try that. Python. Oh, there's no such thing. With a single L. Let's see what that does. It actually, when you say get the keys, it's an array with all possible key combinations in here. So it's the full keyboard essentially. And for any key that's pressed, the value will be true. That's a nice quick lookup. Interesting. So this KW would actually be some kind of integer value. This KW, SKA would actually be just a numerical value. It's a pity my machine hasn't finished setting this up. Oh, let me reload quickly. Let's see what that does. Let's see if it's understood the language model. KW, KS, I don't know. Let's just minimize that. Install the linter as well, and then just do later. Okay, so this does pip install pylint as a user, so it will collect whatever it needs and install the linter so that I can actually see what the code looks like. I was hoping the autocomplete would kick in, but that's fine. So we say player position y minus equals 300 times delta time. How is delta time updated? Delta time equals clock.tick in FPS divided by 1000. I'd love to know what this DT is, but let's see what it does. It's just frame rate independent physics that you end up with. So let's it's still running somewhere, right? Actually, where is it? Where is it? Where is it? Where is it? So what was it? WSAD. So ooh, nice and smooth. I don't like the colors purple and red, but it gives us a nice smooth transition. So this doesn't look great. What I want is pink stars falling in lines, and I want it to follow the mouse. So the first thing I would need to set up would be an array that contains the pink stars, and I want them to look very similar to, where's my little button that shows me the desktop? Let's see. I want it to look very similar to this, right? This is something I wrote in C++ a long time ago. You can actually catch this on my YouTube channel, youtube.com/c/Abdul, and you'll actually see how this was created. So I want something very similar to this when I'm done here with the setup. So let's see what we can put together. I don't have much time, so I'll most likely just pause a little bit and start coding something. Just give me 1 second. Okay, so I added in, as you can see, my linter is now actually standing in my way. I need to go sit and configure it. But all I did was I added in the random module. I added in this concept of a number of stars. I set it to 300 arbitrarily. Keys are still just keys. In fact, I don't need that. That was part of debugging. I added this function to generate a star. As you can see, I literally ripped that vector2 instantiation from the example that I found here already, and all I did was I used this random module that I import here to go and get a random integer up to and include between this range, including the start and end. So between 0 and the width of the screen, which is 800. Somewhere in between that range, including 0 and including screen width. So I'm getting random int for the vector2 would be the x position, and the same for the y position with screen get height. So anywhere on the screen, I'm set up a layer, and a layer basically is just a value between 0 and 3, including, right? Inclusive, sorry. Then I said here is a list, a comprehension. I said stars equal the return value of this function, which is just a little object here. For actually that's not an object, that is a dictionary, but for I in range num stars. So it goes from 0, it counts to 1, counts to 2, 3, 4, 5, all the way up until 300, and it takes the return value of this function, which takes this I, which I'm again not using, and just populates this this array over here with the return value of this function 300 times. As you can see, while I'm polling for events, I say see if it's a quit, which is a little X on the button, on the X button on the window. If it's a quit, I quit. If it is not a quit, I try and fill the screen with black, and then for each star, as you can see, I look up stars I position, which is this this vector that I set up here. I draw a circle that is purple and 4 pixels in size. I'd like to change that to 2. Then I don't interact with key presses, not yet. This will maybe fall into some kind of actually I don't know what I'd use that for, not yet. I don't have an idea of what I'd like to fully build. I just wanted the pink stars. So what I'd like to do is each time I draw a star, I would like to update its position, and then move it maybe down the screen, but I'd like to move it by the speed of the layer which it appears on. That's gonna be a fun one. So I'd like to say I'd like to access this stars I pause. What is inside this vector2? Let's see if my linter is smart enough to load this vec2 for me. Nope, It's not going to load the vector 2. I'll just try and address it as x and y. So I'd like to do stars I dot pos dot x plus not the x, sorry, the y. I'd like to make it 4 plus equal some value times the delta time. So I'd like that to potentially be 30 times delta time times the layer. No, that would not give me a good enough value, because there will be some stars which actually stand still because they would appear on layer 0, or the layer value would be 0, because this random here is inclusive for layers. So 0, 1, 2, 3. So potentially maybe plus stars I dot layer, so that would be 0 blah 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 times dt times 10. Let's see what that does. I'm literally just sucking these values out of thin air. I have no idea what this will do, but let's see if I try and run this. So what I would do here is python falling.py. What does it do? Here we go. Pink stars falling in lines, very quick. But as you'll see, very quickly you'll start to notice that even though you do get this little kind of 3D effect type of thing, we are still seeing stars that just continue on forever. So we do need a bounce check here to be able to move the star back up to the top of the screen, right? So let's kill that and get these stars cycling. What I'd also like to add here is an array of colors from which we can choose. We know there's only going to be 4 colors, so I'd like to go and look at the documentation for this PyGame draw circle quickly and see how I specify an RGB or maybe an HSV color value that I can then rotate along the wheel by layer amount. So one sec. Okay, so let's go back over the code quickly. We said there are 4 colors. I created another generator function. This is just a plain old generator. It returns a brand new color, 64 plus 32 times I, so that would be R. I'd like to potentially make this also 128 to give it a nice purple tint. If I can get that there. So pinkish color, 92 plus 32 times I, blah blah blah. So I'm actually using the I over here. Then another comprehension, list, array comprehension, or list comprehension as it's called in Python specifically. I say I'd like to generate color for each I in this range from 0 to 4. So over here I'm saying just return a color. So it's populating this thing with 4 colors, right? PyGame color objects. These are simple RGB values. I just wanted to make the colors consistent, so every time I run it, I would not like to do randoms. I'd like to just have a color palette that's set up. We can fine-tune this and tweak this later, and then while it's running, I've added in the check. So here I draw a circle on the screen with colors that is selected based on the layer of the star. So again, there are 0 to 3 layers, right? Which means 4 in this world, so I just did -1 over there for consistency, so I can actually change this to whatever I want, and the generator will still work and the indexing will still work based on the position, and it's 2 radius of 2. Actually it might be diameter of 2. I'll look on the screen now, with the position of the star being added to each time we draw the frame. This dt, whatever actually does work, but I'd like the dt I'm very curious what happens if I do this. Oh, you can't do that in Python, right? Yeah, Python doesn't have that inline comment. Let me try this without modifying the original formula. Let me just put that in there and comment that out. So there. And then if the position goes over the height of the screen, I just reset it back to the top over there, right? So you should be able to see at least something sharp on the screen. Again, I don't care about the key press. I just flip the display and then check, get the delta time. I expect this to be a little bit on the slow side, so let's see what's happening. Pretty is as pretty as. However, the stars on whose layer value is 0 are not getting any kind of delta. So over here it's saying 0 times delta t times 10, so it's not getting any kind of moment impetus, right? So let's do just plain boarding 5 times dt plus the layer affected value, and then do the stars from that point on. Let's see. It does not auto reload, I believe. Yeah, I'm not seeing the auto reload. Okay, so we now have stars that show up in different layers and with different color values. So 64 times 3, 6, 12, 18, 4, 12, 192. I'm wondering about the colors over here. See, if I do 128 plus that, but if I do 64, plus 42, 4, 12, 16, it has to be 96, plus 42. I'm literally just playing with the values at this point. I'm not. Ooh, that is pretty. And there's much more variance between the brighter stars, which are closer to you, and the dimmer stars, which are supposed to be further away. So I'm using layer as an implied Z value. I'm not doing an interesting range of values. I'm just doing just a plain boring Z value. I'd like more red. I'm thinking maybe I should fix the red to a high value and then just vary the blue and the green. Let's see what that does. So if I fix the red to a blue value, so I do 1 and 2 plus maybe 12. Yeah. Let's see. So I do that. What is this? What is this bar? What is that? I've never seen that before in VS Code. That's interesting. Here we go. So we get a little bit more pink, orangish colors, and the red shifted stars, just like in an actual galaxy, you get the red shifted stars a little bit further away. This looks pretty. So the closer and brighter stars should also be larger. How do we do that? We do 1 plus layer. So I would like to do 1 plus layer. So if I'm going to use this each time, I might as well extract it into a variable, right? So I would do layer equals that, and then I don't have to repeat this lookup. Over here, we're using this layer value, and my word, I think I missed it. And then I'm happy with the way the movement functions. So I'm completely fine with movement over there. Let's just separate out this if into its own line, so that should look a little bit better. So screen fill with black for each of the stars. I'd like to extract the layer from it. Draw the circle 1 plus the size. So this I don't think is going to look that great when we use it, but let's try. Ooh. But now at this point you'll actually notice a problem, that the closest stars actually look like snowflakes and not like stars anymore. I don't mind it doing that. It actually looks quite pretty. Is it possible to then resize this window? No. Is it possible to maximize the window? No. But that is a fairly nice introduction to PyGame, right? So let's clean up this code a little bit. The keys I'll use in there, the flip I'll use in there, the delta time I'll leave in there. Oh, the generators I'll leave in there. The example file, this does not mean anything anymore. This is just my initial setup. screen PyGame display set 800, so I'd probably do 1024 by 768. Let's see if that actually works. I'd leave it at 300 and the colors at 4. I would probably fiddle with the scaling at some point. Let's see what it does. Oh, that is immensely pretty. I'd like to go check the documentation to see how do I get this window to actually maximize onto the full size. So just give me 1 second. It should take us a couple of seconds to actually just go and check that out. Okay, very quickly, let's run through the code, the changes I've made. I don't like this little purple thing. I don't know what that is. I'm going to go Google that after we've done the video. But again, let's look at what we've done here. So you can see the code changed. I said go get me the display modes. And what this does is it lists for you all the possible display modes for your current display driver, right? The defaults here say get me what is a scaled get me this display modes that I can full screen into, right? So get you your possible resolutions that your screen can go into. It is sorted into largest to smallest. As you can see, 320, 200 is right at the end, whereas the largest possible value is right in the beginning. So what I'm doing is I'm just selecting the largest possible value in the beginning of that list. So instead of a fixed window dimension, I'm saying just go get me the largest screen size I can get for this window, right? So this is now just based on your own graphics capabilities for your own machine. Then nothing's changed here for generate stars, generate colors. I just changed these values a little bit. I wanted a more red and less blue. So as you can see, I made the highest possible red, very low green, and a medium blue, right? Then the comprehensions are the same. While running, I changed this a little bit so you can actually still use the PyGame quit function that you would have if you had a little X on your window. But I discovered very quickly that when you use this largest display mode, you don't actually get the little window decoration bar over here. It's a borderless window essentially. So that's a little bit on the weird side that I'd like you to watch out for. Then you'll see I'm still filling the screen with black. I'm still doing this layer thing. I actually went and found that this value over here is the radius. It's not the diameter, it's the radius. So I just cut it in half. So I say 1 plus the actual layer, cut it in half, get a little bit smaller stars that don't look like snowflakes anymore. This position over here is the circumcenter, or the center of the circle. So center of circle and radius. That's how this draw function works for a circle. Here I modify the position. Again, nothing changed here. I do the check, the boundary check, bounce check, see if it's off the edge of the screen at the bottom, and then just shift it back up to the top. So wherever it was, that image would just scroll repeating. There's no randomness applied to the X position at all. I could apply some randomness over here to the X position, but again, not really bothered. Over here, this is modified slightly because I don't have the little X button on the top of the window anymore. I just check if somebody hits the escape key, I set running to false, which exits the loop and quits the program, and that should be it. So again, 56 lines of code, including some interesting comments. Let's save that and run it and see what we get. Beautiful. This is very, very close to what I originally wanted. This looks almost the same as my desktop. I'm very happy with this. I would probably add some sprites and other characters into this at some point, but I'm keeping this code. Hit escape. There we go. As you can see on the terminal, we're not getting any exceptions for the escape, so all we need to do at this point would be you can also use get add dot initial commit pink stars falling in lines. I love that quote. It just makes so much sense. Now we do get push origin. What is the branch name over here? Main. I see master is a thing of the past now. By default it goes to main. Let's see if I can push from here. Code is pushed. You can see I've been going quite a bit over here, but what I'm interested in is this. If I refresh this now, I should have one file over there. Beautiful. So this is exactly what I wanted, and this is the URL: github.com/legion/falling. It is public, so go ham, make branches and issue pull requests for me to actually go and review. Have fun, guys. As always, it has been a blast.